going to start by solving number one. So for number one, for the following system of equations, without using your calculators, graph and find the point of intersection. So before I even start, I'm going to start by labeling my equations. So I'm going to call this equation one, and I'm going to call the second equation equation two. This just helps to make things look more neat and easier to see. Now what I want to do is I want to isolate for y for both of my equations. So in this case, equation one is already isolated for, so I don't have to do anything with that. But equation two is not in y equals 2 form or y-intercept form, so I want to isolate for it. So let's start by doing that. So equation 2, 3x plus 2y equal to 8. So there are a lot of ways we can isolate for y, but for me, the easiest way is to keep it on the left-hand side and move everything over to the right-hand side. And once I do that, if there's a coefficient in front of y, I just divide by that coefficient to everything. So in this case, I have 3x plus 2y. I'm going to start by subtracting 3x from both sides, because if I do it to one side, I have to do it to the other side at least once. So 3x minus 3x is 0. So all I have left on the left-hand side is 2y. Now on the right-hand side, because I subtracted 3x, I have to subtract it to the right-hand side. I now have minus 3x plus 8. Now I'm left with 2y, but what I really want is y. So I'm going to divide everything by 2. And the reason I divide everything by 2, instead of just dividing it once on the left-hand side and the right-hand side, is because, remember, when you multiply and divide, you have to do it to every term, as opposed to adding and subtracting. In this case, when I do divide everything by 2, I have, 2y divided by 2. That should just leave me with y. Negative 3 divided by 2. Well, I can't reduce that, so I have to just write it as negative 3 over 2, x. And now 8 divided by 2. That's 8 over 2. So from here, I try to simplify or reduce anything that I can reduce. Again, negative 3 over 2 can't be reduced any further, so I leave it as negative 3 over 2. And then I just keep my x term there. But 8 over 2 can be reduced, and I believe 8 divided by 2 is 4. So instead I write plus 4. Again, this is my equation 2, which I'm pretty much isolating y for. And then equation 1, I didn't do anything to equation 1 because it was already in y-intercept form. That's 3x, or y equals to 3x minus 5. Now that I have both of my equations in y-intercept form, I'm going to go down to my Cartesian plane here and start plotting them onto the graph. See, now you see why it's useful, because when I'm in y-intercept form, I see the y-intercept and the slope. So for equation 1, I notice that my y-intercept is at negative 5. So I count down. 1, 2, 3, 4, 5. I have a point right here. Now I know my slope as well. My slope is 3. Because my slope is 3, I go rise over run. I let it equal to 3 over 1. Because, technically, this can just equal to 3. But I read it as 3 over 1 because my rise is 3 and my run is 1. And remember, my run is always going towards the right-hand side, but my rise can go up or down, depending if it's positive or negative. If my rise is positive, I'm going up. If my rise is negative, I'm going down. But my run will always go to the right. So in this case, it's 3 over 1, so I go 3 up, 1, 2, 3, and 1 to the right. And I keep doing that. 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. And 1, 2, 3, 1 to the right. Now I can connect these points together, and that is my equation 1. Now for equation 2, my y-intercept is at 4 because, as you can see, it's plus 4. So 1, 2, 3, 4, plus 4 up here. And then my rise, for this case, my rise over run, my slope, is negative 3 over 2. That means I go down by 3 and I go to the right by 2. So let's do that. 1, 2, 3, 1, 2. Okay, another point here. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Now I can connect my points. And as you can see, when I connect my points, both of these lines are intersecting at one point. This point right here. And this point, if I count it, 2 to the right and 1 up. So 1, 2, 1 up. This point would be 2, 1. And this is what I'm looking for. This is my point of interception, which is also the solution to my system of equations. So now that I found that point, I can say that the solution, or point of interception, but anyways, the solution to the system of equation is 2, 1. And again, this is my y-intercept. Like these are my y-intercepts here. And these two are my slope. That's how I was able to plot these equations 1 and 2 in y-intercept form onto the graph.